We are going to be talking about a wallet that we built at our company, TokenSoft. And, a little bit about me. So I did live in Atlanta for a few years here, and I worked in sort of the enterprise security space, so building security software for big companies. And currently, I'm a co-founder and CTO of TokenSoft. TokenSoft was founded in 2017. We build a lot of software and we work with a lot of teams, but we sort of work behind the scenes. A lot of what we do is helping clients do regulated and compliant security token sales. So a lot of times what we do is we automate compliance, AML, KYC, investor accreditation, all of the issues that you don't want to have to deal with manually when you're dealing with a lot of investors. And so we worked with like Tezos, Hashgraph, Keep, with some of their token sales and fundraisers and things like that. And the newest thing we've been doing is wallet infrastructure. So it's sort of interesting. We're going to be talking about Knox Wallet here and why we built Knox Wallet, some of the problems we ran into, and how we made some decisions as we were building it. And the problem use case we had to solve is we were dealing with our clients who are raising funds in crypto. And so if these clients are bringing in tens of millions, hundreds of millions of dollars potentially, how do we help them store it and keep them from either getting hacked and the funds being stolen? In the beginning of the ICOs and the token sale boom, there was a lot of companies who lost money. Either they got hacked, or even there's much people that said they got hacked and stole the funds out of the company as well, right? So how could we prevent this from happening? Essentially, if any of our clients or any of our customers got hacked or lost any money, that would be worst case scenario for us as a company. And we started off using open source solutions to try and do this. What we realized is that there wasn't any sort of existing solution that was geared towards enterprise clients. So these are businesses who want to hold funds. There is a lot of consumer grade stuff, and then there's also some pretty low level tools, but they were not geared towards normal human beings being able to understand what was going on with the wallet software, right? And a lot of the people we work with are just like business people, accountants, compliance people, things like that. So like a CEO of a company, he is not going to be potentially super into cryptocurrency and understand the low-level protocol of sending transactions on the Bitcoin or the Ethereum network. They really just want a secure way to store the funds and then be able to use it. So a lot of these tools that we used in the beginning, our clients would have money they'd need to move, like let's say they need to move $1 million to an OTC trader to sell it because they wanted to convert some of it to USD. And they would call us up every time they wanted to do this so we could walk them through the steps because the existing software was so confusing and hard to use. What we sort of realized with doing this is that there's, by design, when you add security features to wallets, it introduces friction on purpose, right? So you want there to be sort of checks along the way when you're trying to withdraw money, especially large amounts of money, where multiple people have to agree to it. Multiple people have to be able to look and check and make sure you're doing the right thing. But there's also like friction in these wallet software and stuff that we don't want. And we'll talk a little bit about that. And finally, like with our clients, they're holding large amounts of crypto. So the consumer wallet that you have on your phone, that's just a hot wallet, you don't want to use that same security model as somebody who's holding $100 million. So this is sort of the design decisions we had to make along the way to figure out how to build a secure wallet, but make it usable as well. So, the idea is to remove the friction you don't want, but leave in the friction that you do. And so as we were building it, we sort of built it with the model, a 3-layer security model. And so these are the 3 things that we focused on to implement the security measures of the wallet. And like the first level is that we're using hardware signing devices. So, the idea is to be able to tell a business person, here's this hardware wallet. It's a physical thing. Keep it safe, right? They know that they could put it in a safe at their house or in their office, and they understand conceptually how to store that in a safe way. If you get, say, here's a digital number, store it safely on your computer, they're not going to really know how to do that. So the idea is that the hardware wallets protect the keys from being stolen. And just in general, like if you're storing over $1,000 in crypto, you should probably be using a hardware wallet, just as a sort of rule of thumb. If you're storing $20 in crypto, it doesn't make sense to buy a $100 hardware wallet to store that. The second level of security we use with our wallet is offline signing. So, the idea is that we want to do the signing of the transactions on a secure device that we can confidently say is not running malware. So this means it's a computer that has never been connected to the internet. It's not connected to any other devices that are connected to the internet. And, the whole thing is there's some attacks that could happen if there was malware on the device where you're doing signing. So Jameson yesterday showed like some malware that when you copy a Bitcoin address into your clipboard, it replaces it with a Bitcoin address that looks similar to the one you wanted to send to, so you might not catch that you sent it to the wrong one. The other sort of attack is to have malware running on the computer, and even though the software that you're using to do the signing is telling you you're sending, money here, under the covers it could intercept that payload, send it to your hardware device, and send it over there. And you may not notice it when you go to confirm it on the hardware device. So we want a clean, environment to do the signing that we can be relatively sure that there is no malware getting in the middle of it. And also there's like a theoretical attack, right? Like we have seen, for example, the Trezor hardware wallet, there was a vulnerability where you could steal the keys off of it. So we want to also make sure that that sort of attack is mitigated as well. And even if something was on the machine, it was able to steal some information, steal your private keys, it can't actually send it anywhere because it's not connected to the internet. So this provides another layer of security there. And so the third piece, and this is the one that makes it a little more hard to use, just usability-wise, is around multisig. So, this actually protects against a lot of things. It protects against a rogue employee. So, if you're in a company and you have, co-founders, if one of the co-founders has the ability to steal all the company's money, then that's not good. If you get in a fight or an argument, and they could decide to freeze funds and hold the company hostage. There's also, people stealing funds from the company. There's also, this, whether it's whatever actually happened or not with this latest exchange where the CEO actually died. They said he was holding the cold storage wallet keys and nobody else had them. So this protects against all these sort of issues. And also, if you just lose your keys, right? That can happen as well. So you've got two other people that could recover the funds if it's like a 2 out of 3 multisig. And the final thing is it does insert additional checkpoints along the way when you're doing a transaction. So if you're sending $10 million, you want multiple people to look at it and verify that you're doing exactly what you want to do before that $10 million leaves the wallet. And so just to sort of hammer home how painful it is to do these 3 security layers with Electrum. This is sort of like what we were telling our clients to do to do this, right? So if there's a 2 out of 3 multisig with Bitcoin using Electrum, you have to go through this flow of users transferring stuff back and forth. So user 1 has to go onto an online computer, open Electrum, build a transaction. They have to save the transaction to a USB. They also have to save the latest version of the wallet to a USB because on an offline device, Electrum needs to know what the latest state of the inputs, the unspent outputs on the wallets are to be able to sign. So you got these files, so then you have to sneaker net them over to an offline machine. You have to load them into Electrum, load the new wallet. You have to open it up, the transaction. You have to sign it. Now it's in a partially signed state. Then you have to save both these files back to a USB, take it back to the connected device. Then you have to get this transaction file to the cosigner number 2. If they're not physically located with you, you have to figure out how to send that in a safe manner. If you just email it, there's a chance that could be intercepted. It becomes a pain. So once user 2 gets it, they have to go from their connected device. They have to do the same thing where they have to copy files to a USB. They have to take it to an offline machine. They have to load it up, make sure they load the right version of the wallet. It's got to be the latest version of the wallet. Load the partially signed transaction. They have to use their ledger to sign it. Then they have to take these files back to an online computer, load them up, and then broadcast it to the network. And so, if we're telling business people that they have to do all these things, they end up with USBs full of different versions of partially signed, fully signed, unsigned transactions. They have dates on all the wallet files that they had to use to send it, and it turns into a big giant mess. So just this user flow of trying to use this super secure setup was pretty hard for them to just wrap their heads around what they're even doing with all these files and transactions and signing. And not to pick on Electrum, but like the usability, if you put this stuff in front of a normal person and ask them to set up a wallet, like the first thing that they get asked is like, what type of wallet do you want? Do you want a standard wallet? Do you want a wallet with 2-factor authentication? Do you want a multi-sig wallet? Or do you want to import addresses or private keys? And it's like, I don't know, like, sure, I guess I'll go with standard. So you pick standard. The next thing you're asked, choose your seed type. So a normal person's like, what does that even mean? And then so they try to read this, and it says, the type of address used by your wallet will depend on your seed, okay? SegWit wallets use BESH32 addresses defined by BIP 173. Now, like a normal person is going to look at that and be like, I have no idea what the heck those numbers mean or what those words mean. And it's like, the websites and other wallets may not support these addresses yet. Thus, you want to keep using non-SegWit wallet in order to be able to receive Bitcoins during the transition period. So, like, this is something that, a normal user can't even diagnose what the right thing is to do, and most likely they just probably hit next on this button. And like when you're doing a transaction, this is the transaction details page that's shown by you. It's really good if you're trying to debug what's going on, but like think of it as like a non-technical user seeing all this stuff. Like like the status is partially signed 4 out of 8. Like I have no idea what that means. I'm trying to send 1 Bitcoin transaction. Why is it telling me it's got 4 out of 8? It's got size, it's got fee, and sat per byte. What does that mean? It's got lock time on it. I don't know what that means. It's got 4 inputs. 3 of them are green, 1 of them is yellow. I don't know what those colors mean. Is yellow bad? Like, is something bad happening? It's got a button for copy, a button for export, a button for save. What do those 3 things, like, what is export versus save? Like, that's a little strange. And then, why is the broadcast button grayed out? So the real thing is, like, all of these super technical things are being exposed to the users, and they're just being overloaded with information that they don't even, like, most people don't even decipher what it means. So this is the Bitcoin side, and as you can see, using Electrum is, a little complicated there. On the Ethereum side, it's even sort of worse in some ways. One is that Ethereum multisigs, if you want to use the same sort of setup, you have to use a multisig contract. Getting a non-technical person to understand how to use a smart contract is a big feat. So you have to explain to them that, okay, your wallet is a smart contract. It's living on the blockchain. It has its own address. There's potentially 3 or more owners of this smart contract. And to get the multisig to do stuff, you have to send commands to it. So there's really 4 addresses associated with the multisig. The way most multisig contracts work is that the smart contract is used almost like a database to store information about the transactions that you're proposing and signing off on. The first thing the user does is try to send a command to a multisig contract. their sending address doesn't have any Aetherium, so therefore it fails, and it's very confusing to see what's going on. So the Aetherium sort of setup is a little bit confusing as well there. And also just like when we first started, like the only way to even interact with the smart contract was basically like for a regular users was to use my Ether wallet. And that was a challenge just to get them to even like, just for us to be able to use that interface was a challenge, right? And then you try to explain like tell them how do you interact with the smart contract? Well, you have to get the contract address, okay, that sort of makes sense. And then you have to get the ABI. It's like, okay, what does ABI stand for? I don't know. I have to go Google that to figure out what it is, right? And so we send them this big giant JSON string that has the definition for how to talk to a smart contract in it. They have no idea what that is. They just copy and paste it in there. And then they get to the actual submit information, and it's like, okay, I'm building a transaction that's talking to the multi-sig contract. So I put that in the destination address. It's like, no, the destination address is where you want the funds to be sent. Okay, got it. And then in the value box, I put the amount of Aetherium I want to send. So I want to send 10 Aetherium. So I'll put that in the value. No, you don't put that in the value box. It has to be in base units. So you have to put 10 followed by 18 zeros behind it before you can send 10 Aetherium to that address. And then they're like, okay, what do I put in the data bytes? Well, data bytes is really used for talking to other smart contracts, so just leave that blank for now. And they say, okay, now I want to send some tokens out of my multi-sig. So, okay, well, now we have to go build a data payload so that you can create a transaction to talk to your multi-sig that's going to send another data payload to talk to your ERC20 contract that's going to tell the ERC20 contract send tokens from one address to another. And so then we end up just generating a big giant data payload that's binary data that they have no idea what it is. So needless to say, the interfaces for Ethereum multisig was very complex, and literally they couldn't do it unless we walked them through every step of the flow. And so we started building our own stuff. It's super interesting, the problems that you run into when you try to solve this yourself, specifically for a single use case. In our case, like one of the things we had to figure out was how to get data from a phone to an offline computer. And we wanted to do it in a way that was very transparent what the data actually was being transferred back and forth. So like if let's say we use Bluetooth, well, you don't know if that was intercepted because you can't actually see what's going on. Do we want to connect the phone to the offline computer with a USB wire? Well, no, because then technically the phone is connected to the internet, therefore the offline computer is no longer considered secure. So we started using QR codes, and we basically came up with this idea of the dancing or video QR code to be able to transfer data between the phone and the offline computer. The Bitcoin transaction size and the Ethereum transaction sizes can be bigger than what can be put in one QR code. So that's why we actually spin it through and show different QR codes, and then we put them all back together to build the transactions going back and forth. So we built a QR code that's got all the data for the unsigned transaction. We QR code it over to the offline computer. We sign it there, and then we do the opposite to bring it back to the phone and broadcast it out. Another interesting thing was just picking which hardware device to use, right? So there's like trade-offs that people usually don't have to think about. Going from a Trezor or a Ledger or KeepKey, what do we use? It's fundamentally it came down to which APIs were the easiest to use, and then also like with Trezor, you sort of get more open software to be able to see, look at the software that's being run on it. Whereas with the Ledger, you get an actual secure element, which protects it, a little bit more from the possibility of seeds being leaked through the USB connection to the computer. We ended up going with the Ledger to start off with, mostly because of the integrations and the fact that it has a secure element on the actual device itself. And finally, doing Bitcoin, what do we do with SegWit, right? We ended up actually going ahead and just doing native SegWit for all of the transactions. And it's sort of interesting to think about if you're building a new wallet and you build SegWit, you're fully compatible with non-SegWit wallets. So your wallet can send transactions to any other address, whether it's SegWit or not. The real problem is, can people send you money? So if those third-party wallets can't send to a SegWit address, then they can't send you funds. So that's really the only problem you might run into. But looking at the usage growth for SegWit and things like that, we said, okay, let's go ahead and implement it now so we don't have to go through some strange upgrade phase later on and have some of our clients be on SegWit wallets, some of them be on non-SegWit wallets, and have that whole confusion about what type of wallets do you have. And that's basically the sort of slides here, and we did want to do a demo, so I'm going to have Ron come up and help me run a demo here real quick. So what you're going to see is I'm going to unlock my ledger here real quick just so we can do a transaction. Secure password. Okay. So okay, cool. So what you're going to see here is on the right here is actual Ron's phone being mirrored to the screen. On the left is the piece of software that would be running on a offline computer, not connected to the internet. And so, how we coordinate the multi-signature stuff and the wallets is all through the mobile app. So everything is mobile first in the UI. And so if me and Ron and another person had a multi-sig together, we would all have this running on our phones. And the mobile app is essentially just a read-only view into the multi-sig wallet. So even if your phone gets stolen, there's no way to send any funds. The worst thing that could happen is your information could get leaked out about how much crypto you have. And so this is running on the testnet. And you'll notice on our wallet, we support both Ethereum wallets and Bitcoin wallets. There can be multiple wallets, so you can have multiple multi-sig wallets on the different chains. And then, there's sort of two views. One is like wallet-centric, so that's what we're looking at here. And so you can see we have like two Bitcoin wallets, one Ethereum wallet up top, and another Ethereum wallet down the bottom. And if we switch over and look at the currency views, we can sort of collapse all those together and say, okay, those four wallets actually have these three different types of currencies in them. So we've got Bitcoin, Ethereum, and then we've got a test token. So the Ethereum wallets support multi-sig. The Ethereum wallets support ERC20 tokens by default as well. So we can sort of show you like you've got 50 different wallets, 50 different currencies. We can collapse that all together and sort of give you like a report of everything that you have. And so what we're going to do here now is I guess there's one other sort of screen that's sort of interesting to look at on the activities here. So this is like everything that's happened in your wallet, all of your wallets together. So you've got incoming transactions, you've got outgoing ones, you've got ones that are sort of in a pending state that might need a signature from another signer before it can go out. So what we're going to do is do a test Ethereum transaction. So I think the panel before us said that Ethereum is a failed project, so we'll see if it works for us here. We're actually going to do a Ethereum transaction to, we'll just send it to a random Ethereum address on my phone. So essentially what we're doing is we're building a transaction that's going to be pulling funds out of a multi-sig smart contract on the Ethereum blockchain. It had a certain amount of Ethereum in it already. We can do things like update the transaction fees, set the gas limit, whatever we want to put here. Should be good. We can add there's some additional options. So a lot of times when you're dealing with, especially our clients have seen like when you start dealing with incoming and outgoing transactions, if you don't make a note of what they're for, you soon forget what that is. And additionally, we can talk to other smart contracts if we want to, if we just want to put some transaction data in there. But just like this stuff is hidden by default because we really don't want normal users to have to think about stuff like transaction data on the Ethereum blockchain. So we're going to go ahead and when he submits this, he's going to get a review page on the right here. So this is essentially telling us what's happening. We're going to be going from our Ethereum 2 out of 3 multisig to mine random address. And we see at the bottom the signing wallet is actually my ledger address here. So this is the address for the ledger that we got plugged in right there. And that would be like if so I'm on my phone, it knows that since I'm on my phone, I'm going to be the one that's signing it. So it has the ledger here. And then so what we're going to see now is like sort of the flow between going from the online device on the right to the offline device on the left. So you see here that there's a QR code. It's spinning around. The offline machine is reading it and loading it up. Once it reads all the data, it puts it back together, and it knows, okay, here's what we're going to be doing. So you see all this stuff here on the left is exactly like we just reviewed on the phone here. So it's just giving us another sort of check to see what we're doing. And then we can go ahead and sign it with the ledger. So right now the offline device is talking to the ledger. He's going to confirm it on the screen on the ledger. And once he does that, the transaction will get signed. And we're going to do the opposite now. So we've got the signed transaction on the left. We want to get it back to the phone so we can broadcast it to the network. So the phone's going to do the exact opposite. It's going to read in the fully signed transaction. And then here we are. We're going to last chance to sort of review it before we broadcast it to the network. And then when he submits this is the command going to the multisig contract that says, hey, I want to move some ETH to James's Ethereum address. So it's sort of interesting here too, like just doing a signature requires transactions to be confirmed on the Ethereum blockchain. So you can see right now we're waiting for this first transaction to get confirmed on Ethereum. So this is running on Ropsten right now. And so to finalize this, we need another cosigner. So this is a 2 out of 3 multisig. Yep. Exactly. So the phone is read-only access. You can build a transaction that you want to try and sign, but you can't do. Exactly. So all the signing's done on an offline device with hardware device. So even if somebody gets a hold of your phone, unlocks it, can get everything on your phone, they can't steal any of your funds. It's like a read-only view into it. Okay. So Ron, you just logged in back as yourself. So Ron was logged in as me. Now he's going to log in as himself on the phone. And you see he's being told here that there's signatures needed on this wallet. So if I logged in right now, it would not say signatures needed. It would just say that there's some pending ones that other people need to sign. And he gets a call to action to go ahead and sign it. And so we see that the signatures, so the transaction we just submitted, it got confirmed. So now it says, okay, signature 1 of 2 is good. Signature 2 of 2 is required now. And so money still hasn't been pulled out of the multisig wallet yet until he goes through the signing flow as himself now. So he can do the signed transaction. And so this is going to do that same sort of signing flow all over again, where it will build the transaction to confirm the second signature on this single transaction. So just go ahead and run through that guy. And so, you know, this still introduces friction, right? Because we have to go back and forth between these devices. But in our minds, that's sort of one of the frictions that we want, right? We don't want the ability for somebody to get the phone and just automatically send funds out. So he's going to go ahead and sign it on his ledger now. So it knows his ledger is plugged in now, unlocked. He's confirming it there. Signed one goes back. And so we're going to scan this. And this will be the second confirmation on the multisig transaction. And so when he sends this, it's gone to the network. When this gets confirmed, it's going to trigger logic in the multisig smart contract, and it's actually going to withdraw the ETH to the wallet on my phone. And so we just have to wait for that to confirm. And that could take anywhere up to like a whole minute to actually go through. But so I think, you know, the interesting thing is, you notice like the stuff we were doing before with Electrum, the user flow was entirely different for that versus Ethereum. With this wallet here, we can train our clients how to do one signing flow, and they can do the exact same flow for Bitcoin, Ethereum and ERC20 tokens. It's sort of interesting because Bitcoin, when you do a multi-sig, you don't have to broadcast any partial signatures to the blockchain. You gather all the signatures together, and then once it's fully signed, then you broadcast it out. So even though these sort of like confirmation steps are happening for Ethereum, we basically just skip those during the Bitcoin signing flow because we don't need to actually broadcast anything. So it's a little bit faster when we do it that way. And again, so we can do the same sort of flow with all the different currencies that we support. And there we go. So it finally got confirmed. And so the funds were sent, a whole $1 was sent to my address on my phone, and been pulled out of the multi-sig on the wallet there. And if we go back, you can see it in the block explorer here on Robston. Right next to this green little check mark is where it's saying it transferred the ETH from the multi-sig to that address. And essentially that's it. I mean, there's some other stuff around sort of tracking, all these things happening. But the big thing is, we built this with a mobile first application, and it's got those 3 layers of security. So it uses hardware signing, uses an offline signing device, and it used multi-sig. And so we combined all that together to sort of build the, a wallet that's geared towards enterprises and businesses who are storing large amounts of funds and want higher level security, but actually be able to use it and have normal business people be able to do it. So that is about it. That's it. So thank you. All right. Cool. We got time for questions.
Hi there. Is there any options to output the fully signed transaction and then broadcast it without the mobile?
Yeah.
You can view the raw transaction.
Yeah, so I don't know if we still have it up. Let's see.
And the second follow-up question is, can we bypass the mobile completely if they don't want to use mobile as part of the solution? The reason thinking is some people are not, they're going to want to have computers that are locked up. I know there's the offline signing, but they're not going to want mobile to be any part of it.
Right, so if you want to roll your own stuff, then you're not going to be using this software, right? So you're going to be using those tools and the existing tools that are out there to build the transactions and stuff yourself. This is specifically built for people that don't want to have to deal with the super low level nuances of being able to sign stuff and broadcasting it manually and things like that. But yeah, we do expose everything. So like our mentality was to expose all the lower level stuff, but not make it up front. So like when we go through the signing flow here, there's actually a little option that says, show me the raw transaction that I just signed, and you could grab it from there and broadcast it. But with the usability first mindset, it's like, let's hide all that stuff by default so that a normal user flow doesn't have to think about, have mental friction in understanding big giant blobs of hex data.
Hi, I have the opposite question of him. Say a user doesn't care about having a hardware wallet and they want more of a trusted system and they just want to handle one transaction on their phone. Is there an option for that? Like, do you have cloud, key holding, or do you encrypt it and put it on the user device so they can just streamline, make a transaction on the phone and then that's that?
Yeah, so this is basically brand new, right? Our first use case is geared directly towards the problem that our clients have, which is their enterprise customers who are storing large amounts of crypto. So the first use case we went after was directly for that. And the hope is that we'll be able to start addressing some other use cases. So like maybe they want to start doing single signatures as well. So there's a few different models that we can think of, right? So this is like the most secure setup. The next one down might be, okay, I still want to do hardware signing. I still want to do offline signing, but I just want to do single sig. Then it might be, okay, I want to do a key on a phone, maybe stored in the secure element or on the phone or whatever, and be able to have like one of the signers not have to get out the hardware and do the offline stuff. And then you could take it even further and be like, okay, maybe There's an enterprise use case where we could hold one of the keys for a wallet, and as long as Ron is sending less than $100 per day, we just auto sign one of the signatures on it, so only he has to really worry about it as long as he's within those compliance reasons. And then like fully, all the way down to all the way consumer, hot wallet, single sig phone, thumbprint on the phone, signed, good to go. So we started at the very high end, and there's a little bit more on the like enterprise side stuff we can do, but I think most people are used to consumer wallets and like the very simple flow, but that is a sort of different use case with like lower amounts of crypto that you're usually dealing with. Right now, it's just Ledger right now.
When I saw that you're building the transaction on the online wallet or on the online device. Could you show again just how the offline device is, like how you're communicating back and forth and getting the private keys out of the ledger to sign and flash back and forth between the two devices?
Yeah. So when you build the transaction on the mobile device, you're connected to the internet, right? So you have to be able to say, what is the current state of my wallet? So on Bitcoin, you have to know all of the current unspent transaction outputs in the wallet. So you have to actually be able to see the network and get the latest view of it, right? On Ethereum, you have to know what the nonces are on all the accounts that you're going to be using. And you have to know the fees. So yeah, you have to be able to say, okay, what are the fees on the network right now? So you do have to be online to build a transaction. Once we build the transaction that has all the information about what you want to do with it, we take that raw transaction, that unsigned transaction, and we put it in the QR code. And so that's sort of the step where we put it in the QR code, and then we transfer it through the air gap to the offline device with the QR codes. So, I'm never connecting my phone to the offline computer. In this case, it was all connected for demo's sake, right? So it might have been a little confusing. But we wanted to show both the phone and the offline signer on one screen. Exactly. So right now we tell our clients just to use like the cheapest MacBook Air and just use that because it's pretty straightforward to set up. But the main thing is it's never connected to the internet. You're not using it for browsing the web or checking your emails or anything like that. This is a device that's specifically for signing and is used for that one purpose only. Right. Right. And it is a cost, but the idea is if you're storing $50 million in crypto, then you're willing to spend extra money on stuff like that.
Hi, thank you for your sharing. I have some questions. I try to understand it better. Like, is that the user interface is like Venmo, so that everyone could see the transaction, and is the data is stored in everyone's computer, or how does that work?
Yeah. So each user has an individual account on the mobile app, and the only thing you can see is wallets that you're a member of. And it's sort of interesting, on Ethereum, the multi-sig contract is already on chain, so anybody can see what's going on with that wallet anyways. So, I could watch somebody random, you can watch somebody's multi-sig from like an exchange and see all the money coming in and coming out. So that sort of information is just sort of exposed in Ethereum. On Bitcoin, it's a little bit more private. You can only see, like, when you generate new addresses, you don't know that they're coordinated with other addresses, so it's not easy to track stuff as much as on Bitcoin. But the main thing is, this is an app. It's hosted by us, so you're talking to our Bitcoin node, our Ethereum node in the background through our web APIs. So you've got the phone, you're logged in as a user. You can only see on the phone, you can only see the wallets you're a part of. And so there is data going from the phone to our servers to the blockchain. This is not like a public app like Venmo or whatever where I can just say, hey, send Ron some money, and I think Ron's got an account, sort of thing. You do need to know the actual crypto addresses that you're sending the funds to. It's not like Venmo where you're posting public what's going on. Again, this is for enterprises and businesses who, almost all of them do not want, they want some level of privacy as much as they can get on the blockchain, which in some cases more or less. But yeah, I don't know. Does that answer the question? So like some stuff is public just because it's on the blockchain. The app stuff is, you would be paying us to have this wallet basically. So you're sort of implicitly trusting us to help you set this stuff up and use it.
Hey, if I have an existing Ledger Bitcoin multi-sig setup, can I use it with Knox, and vice versa? If I set up a multi-sig Ledger Bitcoin wallet with Knox, can I at later time switch to a manual process?
Right. So usually what happens is we would just set you up with a new wallet and you just sweep the funds into it if you wanted to use it. Or if you wanted to go from this to something else, you just sweep the funds out of this to another, whatever the other solution is. In Bitcoin, there's a lot of nuances. So one is that we're doing native SegWit stuff. So if your existing one is not native SegWit, then when we loaded it into here with the XPubs or whatever, it would not see the old transactions because it would be looking for the SegWit versions of the addresses for incoming payments. The second thing is the way you derive addresses. There's some standards out there for it, but everybody's got their own implementation. So like Electrum does, so even if you use the same ledgers and you go to Electrum, they will generate one wallet, one address, and then you go to another piece of software, use the same ledgers, everything, it'll generate a different one, and it's because internally it's actually using different flavors of these standards to build the multi-sig receive addresses. So it's very hard to port wallets from one to another for those sort of like legacy Bitcoin technical reasons. But in our client's case, most of the time, we set them up with a new wallet, we teach them how to use it, and then they sweep their funds into it.
One thing I would add, I think, is from like a quality control standpoint, we would want to know that our clients were being set up with fresh ledgers because we don't know what machines they've touched and how they've been using them previously.
So I saw you had a login, email password login. Can you just explain what that account login was for? I saw that you were able to sign out of his account and then log in with your own and pull down.
Yeah.
Yeah, so for the purposes of the demo, simulating two people who are in a 2 of 3 multi-sig together, the accounts are, we're associating potentially multiple single SIGs with one entity. So say you were managing several multi-sigs, either with one ledger participating in multiple ones or several ledgers participating in multiple ones. We still want to be able to give you the same flow. So we associate several single SIGs on our database with an individual. But we can't store your keys. All we can know is your public address.
Okay, so the keys are on device though. Everything's actually on
the
device.
keys are on this, and they're on a hardware security module, so theoretically they can never leave the ledger itself.
So we can get the public addresses off of the ledger, but we can never get any of the private keys off the ledger, right? So like I said, we can get we know the Ethereum address associated with that ledger, and so we know that that address is associated with my account. So our services are, when you log in, our services are saying, okay, that's James. I know he's got these 3 ledger addresses associated with his account. These 3 ledger addresses are associated with 5 different other multi-sig wallets, and pull down the information for James's wallets and show it to him in the UI.
So, but the funds are so the phone never actually has funds on it.
Right, so the phone is a read-only view.
Yeah.
There's no way, like I said, even if somebody steals your phone and unlocks it and has access to everything on it, all they can do is view your wallets.
So if Apple shuts your app down and takes it out of the App Store, as a business, what is my recourse?
Yeah. So, I mean, the good thing is this is all cryptocurrency stuff. It's all, it's all following, anything on the blockchain, is basically, you can replicate it, right? So the fallback for Ethereum is you go back to that My Crypto interface and you manually interact with the multi-sig. Like that can be done. And then Bitcoin, you can do the same sort of thing with building the transactions to sweep the funds out. The main thing is, the saying is always, not your keys, not your crypto. Well, in this case, we never hold the keys, so it's not our crypto, it's yours still. So no matter what, you can still recover the funds. Can you say that again?
Would you provide customers with some alternative way, like specification, how to do it in Electrum or something?
Yeah, I mean, we would definitely. I mean, the thing is, we're paid service, so like it's not like we're just an open source free thing that people might start using and then we can just disappear. So like there would be actual contracts between us that would stipulate what scenarios we couldn't just disappear, I guess, is the sort of thing. Like there'd be repercussions to that. One more.
So as far as a paid service, I'm assuming that's like a monthly subscription. And is there tiers based on amount, or is it a flat fee?
Yeah, so it's sort of interesting. When we started off, we like I said, we just tried to use open source stuff for our clients to use. This has really mostly been used with our clients just in existing contracts that we're already doing services for these clients, and we want to give them an easy way to store the crypto. And now, as we're actually going out and selling it separately, or starting to, we're just hitting app stores and stuff right now with it, actually. So, but it will be a service that's.
Yeah, and we can direct any expressions of interest to tokensoft.io/Knox. There's like a form you can fill out to get a more in-depth demo and sort of tackle some more of these like business-specific questions.
Yeah, I know BitPay, CoPay, those kind of services have like an extra security feature where they obscure your address by having several addresses that somehow magically route to your address. So you're never certain exactly what address is going to be used, so no one can ever track you, in a sense. Do you support that now, or are you planning on supporting that security feature in the future?
Yeah, so it behaves differently depending on what chain you're on. So Ethereum, you have one multi-sig smart contract address, and that never changes. On the Bitcoin side, every time you receive new Bitcoin and you give somebody an address to receive Bitcoin to, it will generate a new Bitcoin address for that. So Bitcoin, you're not supposed to reuse addresses. Ethereum is account-based, and so you do reuse addresses. So it behaves a little bit differently. But yeah, so on the Bitcoin side, every time you receive funds, it's a brand new address that's never been used before. So that's why I was saying it's a little bit more private on the Bitcoin side than it is Ethereum. But that's just sort of the protocol, the Bitcoin protocol. All right. Cool. Thank you, guys.
All right.